Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. And today we have the Sundown Audio SCV7500 output section here that I am going to briefly demonstrate how I just quickly go about resolving the issue of the output section of these particular style of amplifiers. And as you can see in the upper right hand corner, let me see if I can point to it right here. You're going to see the meter value reading. Let me make sure it's still active. Sometimes my software gets a little funny on me. There we go. So it is active. And as you can see, I like to use resistance. Resistance, in my opinion, just tells me so much more when it comes to the expected values of a circuit. So yes, I am one of the guys that uses resistance to troubleshoot and diagnose problems. Now these boards have 4 IRS 21844 drive ICs. So I think first what we have to do is just kind of quickly break down this output section and how it's put together. You have 4 IRS 21844 ICs. And each IC has a low side and a high side. And then, so a quick way to do this is you just count one side of your output transistors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 transistors per side, and you have 2 drive ICs per side. So you can easily tell that each high and low side has 3 transistors on it, just by doing the math on this. So you can see it as 6 and 6. One group is 6, high side and low side, goes to one IC. The other group is 6, high side, low side, goes to the other IC. So as you're going around and doing your resistance checks, you kind of have to check, or at least understand the sections of these amplifiers. If you just do some sporadic checks here and there and see that you have excellent values, well, you may miss a bank that's shorted. So when you go to fire this thing up and the rail voltage builds, it more than likely will go up in smoke. So the first thing I do is I just pull the board out, and you can already see I have some transistors tipped. I was going through this before I decided, hey, let's go ahead and fire up the camera just so I can show people how I am doing this. So I'm just going to start off on one side, and I'm going to check the resistance value between gate and source. So 95.54 ohms. So again, these are in banks of 3 high, 3 low. So the first 3 are going to be your high side. The low side is usually in the center of these boards. So there's 1.7 ohms. So remember, we're working with the first one at 95, and the next one is at 1.7. And remember the rule of resistance: the low value is usually the problem. The lower the resistance, the higher the load across that resistance, and of course all that turns into heat. So this is more or less a direct dead short. 95.62 ohms. So remember, they're 3 and 3. So as you can see, I have this guy right here tipped back. So this one is shorted in the bank of 3. All right, sounds like we got some sirens headed to the hospital. Something big happened in town, only in little old central Washington. All right, moving on to the next set of 3. This is going to be your low side. 3.2K, or 3.2, excuse me, 32K, 32K, and 32K. That's what we're looking for. So this bank of 3 on the low side is not shorted, but still you could have a damaged drive IC. Just to let you know, just because this low side is good doesn't mean the drive IC is good. This just tells me which ones to pull out of the board so I can do my preliminary inspection just to verify that the drive ICs are okay. So 1, 2, 3, 1, 2, 3. You'll see that it was 32K across these three. Then we're going to come back to the next set of three, 94.5 ohms. This is the low side of the other IC. So 94 ohms, 0.63. Well, that's a dead short. So, which is the reason why you see this transistor tipped back. And I'll check the next one, 94, and then I'll check. So that was the low side. Now we're on the high side of the other IC. So we are 1.4 ohms, which is the reason why you see it's tipped back. 1.4 ohms is another short across the gate. 95.5 ohms and 95.45 ohms. So that's that bank. So we have three shorted transistors on this side, and it's the same process for the other side. I use my negative ground probe on the gate, positive on the source, 95 ohms. 95 ohms, as my big old hands are across the camera here. 1.1 ohms, 1.12 ohms, which is the reason why you see it's tipped back. So 1, 2, 3, so that's the high side of one IC, and here's the low side of that same IC. 1 ohm basically, so that's why it's tipped forward. I already know that's a dead short because 1 ohm is usually the lowest you'll see on your meter when it comes to these shorted transistors, or half ohm. 95 ohms. 1, 2, 3, 1, 2, 3, 95 ohms, and then we're going to move to the next three, which is going to be the low side of the last IC. So there's the 32K. So when I see 32K here, that tells me pretty much that this bank is going to be okay, because nothing's shorted at the gate, because remember these gates have the 100K pull down resistors. So then we're going to check the last set here, 1.54 ohms. That's why it's tipped forward. You have 1 ohm. Well, that 1 ohm is probably going to be the lowest resistance of this bank. I mean, there could be one under 1 ohm, but usually once I see 1 ohm, then I know that it's bad. 95.47 and 95.74. So that's the reason why that one's tipped forward. And that is how I go about looking for shorted output transistors. This tells me, first off, the kind of extent of the damage. When these things fail, they can fail in many ways, from just simple little shorts to some major trace damage to, I mean, it can get pretty crazy on these boards just due to the voltage that these guys are running. So these are 200 volt capacitors across the rails, and I'm surprised it's really weird how Sundown did this board. They got really small 1000 microfarad capacitors here, but they have 1800 microfarad capacitors on the power supply board. Kind of like they went with a universal power supply board. I'm not sure, but it's kind of odd to see. So then I am going to quickly just cut these transistors out of circuit real quick here. And these are probably the 24N40s. Let me just check real quick here. 24N40s, yes they are. Super common transistor that is used in these Korean style boards. So I do suggest, if you repair amplifiers, to keep a bunch of 24N40s on hand, because sometimes they can get a little hard to find. So I'm just going to cut these out, and then I'm going to show you guys my results of this process. Now we will check the transistor banks again. 32K. 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 That tells me all three pull down resistors are okay. 1, 2, 3. So let's check this. 32K looking good. 32K looking good. Flip my probe leads around. Remember, I used my black lead on the gate. 32K, we're looking good there. 32K, we're looking good there. And then the last section I cut out, 32K, we're looking good there. So that tells me all my pull downs are okay. The gate circuits itself are not shorted. I already went through and verified my gate resistors. These are all 47 ohm gate resistors. These are 2-watt resistors, just to let you guys know if you are confused about resistor sizes. These are the 2-watt resistors. They're about 11.5 millimeters across, I do believe, which the Bourne's resistors fit nicely up in. And I buy the flameproof wire wound 2-watt resistors. But otherwise, this is just a really, really common setup. So from here, you could actually power up your rails externally. You can supply your 15 volts, positive, negative. Then, of course, your reference to ground here for your negative 12 volts reference to negative rail. And you could actually start this board up to make sure that the transistors are functioning, the drive ICs are functioning as intended. Because you can, as long as I have a transistor in each high and low bank, which I do, you can fire this up with a transistor here or there missing. I wouldn't put a load across it, of course, but you can start it up just to verify the functionality of the switching circuit itself. So that's what I wanted to show you guys, how I go about my process of elimination for diagnosing amplifier boards, to get an idea and understanding of what I need to include in the invoice for the quote. So yeah, I do thank you guys for watching. Please, if you have any questions, leave them down below. I will be more than happy to answer any questions I can, assist you with whatever I can, and just try to help build a better repair community. So keep your fingers safe. As I always say, keep your fingers out of the rails. If you charge these things up, make sure you discharge your rails before you work on a board. This voltage can be dangerous. Alrighty guys, thanks for watching. We'll catch you on the next one. Stay safe.